7.3. And like I said before, those were called parabolas. Now they're called quadratic equations. And we will be solving. That's what we're going to do. Now, solving means that if we had a parabola and it crosses the x-axis, it could cross it in two places. Do you see that? The places where it's crossing is called the solution. So if I'm solving, I'm asking where on the x-axis is that parabola crossing. This one has two real answers. They're not imaginary. Okay? It could be that the parabola just comes down and just touches. If it just touches the x-axis, then it has one real answer, and it's called a double root. And we'll probably have some of those, not in tonight's work, but later on. Then there's the situation where it doesn't touch at all. It's just up here somewhere. Or it could be down somewhere, but it's not touching the x-axis at all. This one has two imaginary solutions. Because it doesn't cross the x-axis at all, they're imaginary. So that's going to be our I that we're going to talk about tonight, and we're going to find the definition of I. But that's the way the graph's going to look. So if you put your equation in your calculator and the graph of the parabola is not going across the x-axis at all, you can expect that you're going to have imaginary roots. If it comes down and just touches in one spot, you can expect that you're going to have a double root. It'll say x equals 3, x equals 3, perhaps. And over here, you're going to have two different answers. So that's what we're looking for. The places where the graph crosses the x-axis. That's what we're looking for. And those have many names, and they're interchangeable, and your author loves to give you a different one each time. They're called solutions. That's one thing they do. They can all be called zeros. They can be called x-intercepts. You can understand why, because that's the x place that it's crossing the x-axis. They can also be called roots. When I was in school, they almost always called them roots, but you don't see that terminology very much anymore. But these names are interchangeable, so it might ask you any one of those as they're asking for you to solve. So let's find a problem to do and see how we're going to do it. We're going to start with f of x equals v squared plus 12v plus 32. I know it's quadratic because of the 2. That tells me that it's going to be a parabola, and that's a quadratic equation. Now, I need to set this f of x equal to 0, because in order to solve this, then I want to solve it and set it equal to 0, because the 0 is going to be my y value as it crosses the x-axis for these. The y value is 0, so you want to replace that f of x with a 0 there to solve it. So you're setting f of x equal to 0, and then if you can factor, you want to factor if you know how to factor. That's what you want to choose to do first if you can. So let's think about these rules for factoring trinomials. First of all, a trinomial will factor into two binomials, two little groups, and each group is called a factor. All right, then there are some rules. If the last sign is a plus, then you must, let me pin, I'm sorry I didn't pin tonight. you must add factors of whatever the last number is, 32. If the last sign's a plus, it means you must add. If the last sign's a minus, it means you must subtract. And what are you subtracting or adding? The factors of this last number here. Now that's if it's a simple trinomial. If it's an AC trinomial and there's a number here besides 1, you'll have to multiply those. But that's just if it's a simple one. So I'm thinking, what could I break up 32 into so that when I multiplied, I got 32, but when I add, I get 12? Can anybody?
8 and 4.
8 and 4. 8 and 4. And you want to put your signs on them. You want both of them to be positive to get that positive 12 in the middle. So the v squared is going to break up in the first position number and make it v and v. And then in the last position, I'm going to use these numbers I used over here when I broke them up, 8 and 4. Now then, I'm almost there. I know that this thing is still equal to 0, so I said each factor or group, if you want to call them a group, equal to 0. So I have v plus 8 equal to 0 and v plus 4 equal to 0. So I'm going to subtract 8 and I get v equals negative 8. And I'm going to subtract 4 and I get v equals negative 4. So this parabola is crossing over here on this side at negative 4 and negative 8 is what it's doing. It has two real roots. One of them's negative 8 and one of them's negative 4. Any questions about that problem?
Can we do another one?
Oh yeah, we're going to do a bunch more. We have 17 to do tonight. 17. Okay.
Will we only be looking for the x-intercepts?
Yes.
Okay.
Tonight's assignment is only solving quadratic equations, and they're going to throw a cubic in there, 2 cubics in there, but we'll talk about those in a minute. But you're looking for the places that it's crossing the x-axis. Now, let me tell you that
the page that you,
I'm sorry, what did you say?
I was gonna see if I could get the last word on the page you had it before you put that page up that you wrote.
Oh, okay, that last page.
I didn't get to write it down on my notes. But I just need the last word that was on the page.
This one? Is it this one?
What is it? Yeah, it's a rods. Does it say rods?
The one
It says roots.
Oh, roots. Okay. It's kind of blue. I couldn't see it. Thank you.
You're welcome.
Thank you.
Okay. All right, now then. Now, the second thing to remember in this exercise, and of course, these are lecture notes, so this is kind of over everything, okay? If you can't get it to factor, or you can't think of what factors to use, then you can always use the quadratic formula. Okay, you can always use that. It doesn't matter if it factors or not. You can always use the quadratic formula to find the solutions that you want. And you can do that quadratic formula for any of these situations. It doesn't matter if it's this one, or this one. The quadratic formula will always work if it's a squared equation. Now let's see what the quadratic formula is. If you have something that has ax squared plus bx plus c, that's your quadratic equation that you're going to use. To get your x's, it's negative b plus or minus. Don't forget that says plus or minus. That's going to give you two different solutions there. One with plus this, one with minus this. B squared minus 4AC. And be sure that you draw your line over this part too. A lot of my students want to just draw their line over the square root part, and you don't want to do that. You want to draw it over the whole thing. And it's 2A that's on the bottom. Now, make sure that when you substitute values in, you use parentheses. So let's look at one of these and see if we can do it. I'm going to rewrite my quadratic formula up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. When I get to be in the nursing home and you people come to see me because you know that I was your teacher and you're taking care of me and you're a nurse there, I want you come in my room, I'm going to say, Marlisa, what is the quadratic formula? And you're going to tell me, aren't you? Yes.
Yes, ma'am.
That's what I'm always going to ask when I get really, really old and get into the nursing home. Okay, so what I have here is x squared minus 14x minus 4. Now, if I want to check really quick to see if I could factor it, I could. I need to subtract factors of 4 to get 14. I can't. Factors of 4 are 4 and 1 or 2 and 2. If I subtract those, I don't get 14. So I know that's not going to work. So my choice is to use the quadratic formula. A is 1. It's the coefficient of x squared. B is negative 14. It's the coefficient of the x. C is negative 4. So then I'm going to put it into my formula. And be sure that when you substitute in values into those spots, you're using parentheses. So x equals negative, and I'm going to put b in there, negative 14. Notice how I put it in a parentheses, plus or minus the square root of negative 14 squared minus 4 times 1 times negative 4, all over 2 times 1. And all I did was put in my A, my B, and my C in the spots where it said A, B, and C on the quadratic formula. I think almost all of you have used this at least once. So hopefully it won't be too unfamiliar to you. Now the opposite of 14, negative 14, is positive 14. So that becomes positive 14 there. Leave your plus or minus there. It's going to give you two values. Negative 14 times negative 14 is 196. And let's see what we get over here. 4 times 1 times negative 4. Let's see, this negative times this negative is going to make this a positive. And 4 times 4 is 16 times 1 is still 16. So I have 196 plus 16 over 2. Now then I have 14 plus or minus the square root of, and 196 plus 16 is 212 over 2. Now this might be a hard spot for you, but you've got to take your 212 and figure out how you can break it up so that you have a perfect square underneath there to use. And I already did this one ahead of time. I know that if I multiply 4 times 53, I get 212. I'm wanting to do 4 or 9 or 36 or 100 or 25, anything that is a perfect square if I can, so that I can take a perfect square out of the square root. Let me show you what it looks like. You'll have 14 plus or minus the square root of 4 times 53 over 2. And 53 won't break down. If it would, I would break it down further. It's a prime number. Now that's the square root of 4 times the square root of 53 over 2. And of course, the square root of 4 is 2. So I have 14 plus or minus 2 times the square root of 53 over 2. Now, do you see that 14 and 2 have a 2 in common? And this is the way, I know that some of you just slash these out, and I don't care if you do that or not, as long as you know what you're doing. But mathematically, what's happening is you're factoring out of 2 out of the 14 and the 2. That would give you 7 plus or minus 1 square roots of 53 over 2. And then the 2's would cancel. So what you have for your 2 roots are 7 plus the square root of 53 and 7 minus the square root of 53.
Can you leave that up for a second? I'm still
sure
writing
can.
down the square root part splits up. It's like a little blurry. It's like square root of 4 and 53, correct?
Where,
Okay.
oh, yes, right here is the square root of 4 times
Okay.
53. Can you see that, Lori?
Yeah, I'm still writing it down
Okay.
where it separates. That's where I was kind of like trying to remember. It's been so long since I've done this.
Well, it won't be long after tonight.
Yeah. I forgot that it separates. Like some of it looks familiar, but I forgot that you have to separate the square root if it's not a perfect square.
Yep, sure do. And so you have 2. Now, these are called exact. You're going to find out in your homework that they're going to ask for 2 different things. They're going to ask for exact values, and sometimes in the same problem, they will ask for approximate values. And I think it says to 3 decimal places. So for this first one, the 7 plus the square root of 53, if I want an approximate value, I will grab my calculator and I will put in 7 plus, now if you can see that or not, 7 plus the square root, that I have to hit second to get the square root key, 53, and I'll hit enter. And I get 14.2801. So to 3 decimal places would be 14.280. This one is called approximate. If it has the square root in it, it's called exact. Now then you'll have to do the other side, 7 minus the square root of 53. And that one is negative 0.280. I think they'll want that 0 in front too, by the way. We discovered on the last one you have to have that 0 in front of those decimals. All right, let's do something else, something that we're going to encounter. And then we're going to do 17 of these. So we'll get lots of practice with them tonight. Okay, so if our graph looks like this, it doesn't cross the x-axis at all. So we can expect that we're going to have imaginary roots or solutions or x-intercepts. They're imaginary. They're not there. So we need to know a definition. There's a little I that'll be down at the bottom for you to use in your in your system. There's a little I there. And I is defined to be the square root of -1. Now, there's a whole system of imaginary numbers. There's I squared, I cubed, and I to the 4th power. We will work with the other imaginary numbers later in the course. But for right now, what you're going to need to know is the definition of I is the square root of -1. That's what you're going to need. So let's look at an example. We have f of x equals 3x squared minus x plus 4. And it would be nice if we could just factor this, but this is an AC trinomial because there's a 3 in front. It's called an AC trinomial. And 3 times 4 is 12. Adding factors of 12 to get 1 is not possible. A -1. I could use 4 and 3, but if I add them, I get 7, not 1. So there's no way I can add factors of 12 and get 1. So the only choice I have is the quadratic formula. So I'm going to write it down again until we get used to seeing it. You should be able to do this in your sleep tonight. In fact, before you go to sleep tonight, after you say your prayers, see if you can say the quadratic formula in your head. All right, let's see. A is equal to 3, B is equal to -1, and C is equal to 4 from this particular equation. Everybody okay with that? Now I'm going to substitute them in, and I'm going to put them in parentheses when I do that. So I have parentheses -1 plus or minus the square root of -1 squared minus 4 times A, which is 3, times C, which is 4, all over, remember that line goes all the way over, 2 times 3, 2A. So again, these two minuses make a plus, so I have 1 plus or minus, and I have 1 squared that's negative. -1 squared is 1, so I have 1 minus, let's see what we have here. 4 times 3 is 12, times 4 would be 48. So I have a 48 there. And 2 times 3 is 6 in the bottom. Okay. Now I have 1 plus or minus, and I'm going to do the subtraction. 1 minus 48 is -47. See how I have a negative underneath the radical there? So I have this little trick I can do. 1 plus or minus the square root of -1 times 47. -1 times 47 would be that -47. Now then I can break those up into 1 plus or minus the square root of -1 times the square root of 47 over 6. And I can remember now that my -1, the square root of -1 is I. So I can substitute in right there and have 1 plus or minus I times the square root of 47 over 6. Now, you'll have to write these in complex form. When you get into the I's, then you moved out of the real system, the real number system, into the system called complex numbers. And all complex numbers have to be written in the form A plus BI, where this is your real part. It didn't have an I on it, but this part does have an I on it. So we have to split this fraction up. And I'm going to do it at the same time I write my two solutions. I'm going to have 1 over 6, that's my real part, 1 over 6, plus the square root of 47 over 6, and my I needs to go outside there. Now the second root is going to be 1/6 minus the square root of 47 over 6I. Any questions on that? I will tell you it's a little bit of a challenge to get the answer into the form they want it. Down here at the bottom, you'll have to pick the fraction to get this part in. And then you'll have to make it highlight so that you can put this minus or plus in here. And then you'll have to pick another fraction to put this one in. And then you'll have to pick the square root to put the 47 in. And then you'll have to highlight this part to put the I in. And the I is listed at the bottom down there, so you can just pick it off the list. It's not an I that you would type off of your keyboard. It's the imaginary I, which is a cursive I. Okay, I'm going to leave that there a second and see if we have questions.
I have a question. Why did you separate into two, like the 1/6 minus the square root of 47/6?
That's a great question. The reason I have to is because the author asked for us to put everything in complex form. And any time that you have an I, you've moved into the other system. So you have to separate these into two parts. Now, our two parts had fractions. I have this 6 that goes underneath this 1, and it also goes underneath this part. So I have to split that up into 1/6 plus the square root of 47/6i, and 1/6 minus the square root of 47/6i. That 6 goes with both parts of this, not just one. That's why it's important to draw that line all the way over and not just over the second part, because the 6 goes with the 1 as well as the square root of 47. Did I answer your question or not?
I believe so. So because the I is introduced, the solution's going to be that form.
That's correct.
Okay. I think I got it.
Got it? All right. It's because you're right. It's the I that has to be introduced there, and it makes the situation where you have to put the I and split it up in the
Did
A.
you mean to turn off your overhead?
Yes, I did. I was
Okay.
trying to figure out how to pin this so that I could have you, I think it's going to let me split the screen. I've been trying to play with this, and I think it'll let me split the screen and let me be up at the same time a student asks the question. I'm going to try it and see if it works. But yes, I'll go back to that. How's that? Okay. All right. Are we good? Let's do another one. Sometimes these quadratic equations are kind of funny, and sometimes the author says, well, let's see if they can do this kind and use a different rule. This is 2x squared minus 26 equals 0. All right, now you should notice that there is no x term. The linear term is not there, the x value. When that happens and you just have the squared term and a number, then you can use a method called the square root method. That will make your problem a lot faster. Now, you can use the quadratic formula. You would have to rewrite this to say 2x squared plus 0x minus 26 equal to 0. You'd have to write it like that and use b as 0. But you can always use the quadratic formula if you want to. But if you just have the squared term and the constant with no x term, you could solve this using the square root method. To do that, you add 26 to both sides, and you'll have a 2x squared equals 26. Divide both sides by 2, and you'll have x squared equals 13. Now, this is what the square root method says. It says if you have x squared equals to a, then x equals to plus or minus the square root of a. That's what the square root method says. See how we get that plus or minus there like we do in the quadratic formula? It's the same reason that it's there in the formula. It gives you the two roots that are mirror images of each other. So in our case, if we have x squared equals 13 and we take the square root of both sides, on the right side, we have to add that plus or minus. Now, the square root of x squared, we did that before in the class, and it just makes an x. On this side, we get a positive square root of 13 and a negative square root of 13. So there are your two values, and it's a lot faster than using the quadratic formula, so keep that in mind. Any questions about that square root method? You can only use it if there's no x term. If you don't want to use it, you can use the quadratic formula. You just have to add your 0x in there.
I'm here, Miss Helen.
Who is that?
Billy.
Hi, Billy. How are you, Billy?
Been busy, but I'm
Yeah,
here.
I hear you've been working hard. Okay, let's try the next one. A few of these will be cubic equations. A few of these will be cubic equations. Now, a cubic equation, if I drew a picture of a cubic equation, it would look something like this. If I, my original cubic equation goes down through here and it just has one root that crosses. That's the parent one. But we're going to have things added to these that will make this expand and will make this cubic equation could cross it in 3 places and have 3 roots. And that's what yours will do. Yours will have 3 answers. So let's see what we do with those. We have an 8x cubed plus x squared minus 32x minus 4 equals 0. See how it has all these extra things in here? It just isn't y equals x cubed. It's y equals, it looks kind of like this one right here, actually. Has all those things in the middle. All right, you have 1, 2, 3, 4 terms. This is that 4-term factoring. When you have 4 terms, you group into 2 groups. And don't do parentheses around them because you'll lose your negative if you do that. What you want to do is group underneath. Put those 2 together and these 2 together. If you put them in parentheses, you'll lose your negative and you'll have a sign error. So group underneath. All right, now then, for each one of them, take out a greatest common factor. So I have 8x cubed plus x squared for this one. A greatest common factor would be something that both of those terms have in common. What do you think it would be?
X squared.
That's correct. X squared. So we'll have 8x plus, what am I going to put here when I take out the x squared?
One.
1. There's a 1 coefficient in front of that that's understood there. So when I take that 8x squared out, I'll still have that 1 there. It has to have something in that position. Otherwise, when you use distributive property and multiply back, you won't get that. See, if I multiply back now, I get 8x cubed plus 1x squared. So I have to have something in that position. Now, this is why you don't use parentheses. If your third term is negative, you want to take out a negative something. So what does 32 and 4 have in common?
8.
-4.
4, and
8.
it has to be negative. 8 won't go into 4, so it has to be lower than that. It's going to need to be 4. So if I take out 4, what do I have left inside my parentheses?
Eight x minus 1.
It would be minus, but I took the minus out. See? Now what is it?
Plus 1.
Mhm. Now go backwards before you go further and see if you got the right answer. -4 times 8x is -32x. And -4 times +1 is -4. So that's the correct factoring. You will also know if you factored correctly if these two little groups are the same. The groups should be the same. If they are not the same, you have something wrong. Okay, now what happens is the fronts off of these, I'll call it the fronts, the things that are in the fronts make one little group. So the front off of this one is x squared. The front off of this one is -4. So in one of my groups, I'll have x squared minus 4. The fronts make one of the groups. The other group is the common group. The common group is the other. So the other parentheses, because you're going to have two parentheses, it's to do this. That's what happens with these. And the other one is this little group right here that's the same. Don't try to put it down twice. There's only one of them. It's called a common. It's a common GCF out of this whole great big thing. You could take this 8x plus 1 out, and you would have x squared minus 4 left. All right, now I might have to factor this one right here, but I'm going to use the square root method instead of factoring. I could factor this into x plus 2 and x minus 2 and set both of those equal to 0. But I'm going to use that square root method that I talked about earlier and add 4 to both sides. And I have x squared equals to 4. So x equals plus or minus the square root of 4. So x equals plus or minus 2. So that gives me two roots, 2 and -2. Okay. Now let's do the other one. Subtract 1, and we'll have 8x equals -1. Divide out the 8, and x equals -1/8. So -1/8 is my third root, my third x-intercept, my third 0, my third solution. Those are all the same thing. Okay. Question.
Can you leave that up for a little bit?
Sure can.
And I had a question.
Mhm.
So when you go back up there, right under like the second line of the equation up
The
there.
one- This one?
So, okay, right below that, when you did x squared minus 4, okay, equal, okay, what, like, why did we do that?
Because this is a difference. It's not two factors. I have to have it in the form of something multiplied by something to set each of the factors equal to 0. So I can't have this minus in between there. I have to keep factoring this. So there's a step between this one and this one where I say, okay, this whole great big thing is one thing. Do they have anything in common? Yes. It's kind of like this one up here, where you had two things and you had to have an x squared in common. Well, this is really two things, but what they have in common are that it's 8x plus 1s. So that 8x plus 1 is your common one. That's your little common group. And it's actually like being in the front. And this is what's left over. The x squared, if you take this out, you'll have the x squared left. If you take this out, you'll have the 4 left. And I can only take them out if they're common. They have to be exactly the same. So if when I'm factoring this and this one doesn't look like this one, I did something wrong. Also on all of these, you can graph these. The problem with graphing this one is that it's going to be a fraction, but you can graph these and see that they're going to cross in 3 spots. we'll be actually doing that a little bit later. We're going to graph these. Let's see, this equation started out 8x cubed. I'm just going to use my caret key to cube it. Plus x squared minus 32x minus 4. And see, that's what it's doing. It's crossing at -2 and +2, and then it's crossing right there at 1/8. Now, you could see it on your table, the 2 and -2. You can see that those are zeros. The 1/8 is not on your list because it's not a whole number. You would have to find that. And there is a way we can find it using our calculators. And I'll try to show you that when we start graphing some more of these, how you can use your keys to find out what the other one is, but it'll be a decimal. It won't be a fraction. We'll have to change it to a fraction.
I got a question. So at the bottom left hand side where it has x equals plus or minus the square root of 4, and then obviously the square root of 4 is 2. So the plus or minus is where we got the -2 and the +2?
Yes.
Okay. I just wanted to double check that.
Oh, that's true. Good questions. Anybody else have a question? All right. That's the different kinds that you will have in the assignment. And what we're going to do is start working these problems to see that you can do them. Okay? Do we need to talk before we do that? Or are we good?
I don't know. I feel like a deer in headlights.
Well, if you haven't done a lot of factoring in the last year or two, you probably do feel that way. Factoring is one of those things that kind of leaves you if you're not used to doing it. And if you haven't done a lot of it, then, you know, you're going to have to practice more. It's just a practice thing. It's not a being smart thing. It's just practice. The more you practice, the better you get. And so it's a practice thing. You just have to practice it, be persistent, and keep trying. And this system is pretty good for you because down at the bottom, it asks for similar exercise. And you could just do the same kind of problem over and over and over until you learn how to do it. Now, factoring is pretty wide range. When you are introduced to factoring, it usually takes 2 or 3 chapters to introduce you to factoring, because you go through each of the different kinds, factoring out a GCF, then factoring out difference of squares, then factoring out simple trinomials, and then factoring out AC trinomials, and then you add the cubics, and then you add quadratic, the quatric equations, which are to the 4th power. So that takes a long time when you're first introduced to this. And so if you were absent, if something happened in your life, I mean, you could have missed a whole section of this and not know how to do it. So this is your opportunity to learn. And I'm here, so just ask me and I'll be glad to do it. I've been doing this for since 1970 with students. So I've done a few of these and I can probably help you with them if you'll let me. I can do it. I can help you with them. Okay.
Okay.
All right, let's start on our assignment part of this. And you're going to need to stay with me on it. Even the college algebra folks that really know how to do most of this, there's some surprises in this section. So you want to stay with me at least for a while. Okay, the first
question section for this chapter.
17 in this section.
Okay, thank you.
And we're going to try to do them. Okay, the first one says find the zeros. Let me switch this back. I'm so excited about my new sound and camera. find the zeros, and I put it in myself, ladies. Just want y'all to know that. I didn't ask either of those technical wizards that are men in my life, any of them. I have 2 son-in-laws and a son that thinks they know the world about technology. I didn't ask a single one of them. I did it myself. Just want you to know that. Okay.
And your makeup's pretty.
Do what?
I said, and your makeup's pretty.
Oh, well, okay, let's do this one off the college algebra test to see how you're going to do this. I think I'm going to
Okay.
change my mind and do this other way.
Wait,
Somebody's
just
sound on, so please turn it
it's me. I'm trying to find out how to. Okay. There we go.
off. It starts out pretty easy.
Oh gosh. Please no.
About those prescription lenses.
I'm sorry.
It's okay. All right, now we have 2 factors. See, that's what I was talking about. These have to be multiplied together before you can set each one of them equal to 0. They're called factors. You have to get them in factored form before you can set them equal to 0. Well, this is already factored. It starts out, it's supposed to let you start out easy, but if you don't know what you're doing, you'll go, wait, I thought all these were quadratic. They are. If you multiplied this out, it would be 18v squared. But they've already done that part for you. They've already factored it. And so what you do now is just set each factor equal to 0. They're trying to start you out easy. Now subtract 7 from both sides, and you get 9v equals -7. Divide by 9, and v is equal -7/9. That's one of the answers, the solutions, the roots, all of those names. Don't let them confuse you with all those different names they're calling these. They all mean the same thing. And the second one is v is equal to 3. So in the little box that you'll have to put -7/9, comma 3. By the way, some of you will notice that I did go in and correct. Some of you had, for instance, one like this, you might have put the parentheses around it instead of not putting it. And so if you had the right numbers, I went in and counted it for you. So some of you may notice that your quiz or test scores were different. It's because I went in there and adjusted them if you had the right answer. Let's look at number 2. That's all of number 1. A squared minus 7a minus 8 equals 0. Now, we have to go back to our rules, and we're going to factor this one. This means you must subtract factors of 8. And we're trying to get 7 in the middle. So factors of 8 would be 4 and 2, and you subtract those, you get 2. Or 8 and 1, you subtract those, you get 7. So that's not the one I want. I want this one down here. I want my 7 to be negative. So my 8's going to be negative, and my 1's going to be positive. So what I did was factors of this last number. I broke them up so that when I subtract, I get the middle number. So 8 and 1 will give me 7, but I want my 7 to be negative. So that means my bigger number has to be negative. So I draw my 2 little parentheses, break up my A, put in the -8 and the +1, and then I set each one of those equal to 0. That gives me A equals 8, so the graph is crossing at 8. And the graph is crossing at -1. Any questions? Okay. Number 3 is an AC trinomial. And I'm going to go over the way that you should have been taught to factor this one. I don't know if you were taught the long way or not. This actually is called the Merrill method. This is an AC trinomial. I know it because A is 5 and C is -22. So it's called an AC trinomial, and that's exactly what you do to it. You multiply the 5 and the 22, and you get 110 when you do that. Then you have to follow your rules. This last one means you must subtract. And this time, instead of factors of 22, we're factoring the 110. Factors of 110 to get 1. 1 is the number in front of x there. So if I think about it and I use 11 and 10, I would get 110. And if I subtract those, I would get 1. And I would want my 11 to be positive and my 10 to be negative to get a positive 1.
So with the AC trinomial, we gotta add the A, well, not add, but we gotta multiply the A and the C to come up with the product.
Right.
And then we factor out the 110.
And you're following your rules. You must subtract to get 1 out of the 110. So I used 11 and 10. And if I multiply those, I get 110. That's what I wanted. But when I subtract them, I get 1, which is what I wanted in the middle. Okay, now this is the Merrill method. You can't just draw two little things and factor them. There's a process for this one. Now, I will tell you guys, if you don't like this or you haven't done very many of this or you just can't do it, you can always use what?
Quadratic equation.
If you use a quadratic formula and let A be 5 and B be 1 and C be -22, it'll work. But I'm obligated to show you how you're supposed to factor this, just so that if you can remember to do this, and it's really faster than the quadratic formula is. All right, this is the process. It's an algorithm. You bring down the first term. You bring down the last term. So that's your first thing. Bring down first and last terms. Dr. Merrill introduced this in about 1983, so this is fairly new, actually. Then in the middle, you're renaming. Rename the middle term. And you're renaming the middle term according to what you have here. So I'm going to put plus 11, and I have to add my x on the end of it, minus 10x. And see what's happened here. I've split this 1x up into 11 minus 10. And I used that because those were the numbers I had over here. Then the third step is to group into twos. So I put a group here and a group here. And remember, I'm grouping underneath, not with parentheses, because if you group with the parentheses, you'll lose your negative there. Okay, then this fourth step is to factor out a GCF. So 5x squared and 11x has a GCF of x. So I have a 5x plus 11 when I factor out the x. The third term is negative, so I have to take out a negative something. 10 and 22 have a 2 in common. And do you see that when I take out the 2 and the negative, I get 5x, and the 2 and the negative out of this gives me plus 11. And I stop a minute and I check to see if those 2 little parentheses are the same. If they are, I'm in good shape. If they're not, then I've done something wrong. Okay? Then after you factored out the GCF, you put the 2 groups, the 2 common groups. That will make 1 parentheses, and the front make the other parentheses. So the common group, and you can put it first or second, the common group is 5x plus 11. That's one of your parentheses. The fronts off of them will be x minus 2. See, the front off of this one is x, and the front off of this one is negative 2. Now you're ready to set each of these equal to 0 because now they're in factored form. There are 2 little parentheses with nothing in between them. They are ready to be set equal to 0. So that's what I do next. Set equal to 0. So I have 11. So 5x equals negative 11. Divide by 5, and x equals negative 11/5. And this one, add 2, and x is equal to 2. So my answer will be 2 and a negative 11/5. Okay.
When filling these out online, does it matter which order you put these in?
No, but that's a great
Okay, so
question.
I put like 2 comma negative 11/5 or negative 11/5 over 2. As
So
long
it's
as I
going
have
to
the
be a
correct
box that
information,
you
correct?
can put it in, and you can put 2 first if you want, but you do have to put
Okay,
the
as
comma.
I want to make sure like it wouldn't flag me or something for putting it wrong when I have the right
You
answers.
know, I said that, and I think there are some in one of the sections that wants you to put these as ordered pairs.
Okay.
And if they want an ordered pair, I think there's one or two, maybe 2 problems that ask for ordered pairs. If they ask for ordered pairs, then these are the x values. These are the x-intercepts. So your y values are what?
0.
So if you want them as ordered pairs, it's going to be 2, 0, comma, negative 11/5, 0. That's a great question. You'll have to watch to see which way they want it. It will say at the bottom of it, write as ordered pairs, or write as solutions separated by a comma.
So solutions would be the one in the box. Ordered pairs
Yes.
would be the Y0. Okay, perfect.
They might say roots, they might say solutions, they might say, if they say x-intercepts, they're probably going to want this one.
Okay, thank you.
That's a great question. I worked the problems, and I think there's 1 or maybe 2 that ask for the ordered pairs. All right, let's try. Let's try this one. This is actually number 5. We did number 4 already. Let's try this one. Number 4 was the one that I did as an example when we were using the square root method. And this one's another one of those examples. We're going to use the square root method. Now, somebody remember and tell me why we're using the square root method instead of anything else we've done tonight.
There's no X term.
There's no X term. That's correct. So if there's no X term, it's faster for you to use the square root method. Of course, you can always use what?
Quadratic formula.
And if you want to do that, you're always welcome to do it. And you just have one thing to learn if you're having problems with this. Now you'll have to subtract that 15 across to make it minus 15 and set it equal to 0. But you can use the quadratic formula and use it in that form, the 5x squared plus 0x minus 15. But let's do, it's faster to do the fast method. You'll have square root x squared equals 3. So x equals plus or minus the square root of 3. These are exact values because it has a square root. If it has a decimal, it would be approximate values. So your two roots are the square root of 3 and negative square root of 3. Okay, let's see what 6 is. 4x squared plus 20 equals 0. It doesn't have an x term, so I'm going to use the square root method by subtracting the 20 from both sides, dividing both sides by 4, so x squared equals negative 5. So x equals plus or minus the square root of negative 5. Now this is where I've got to remember that I is equal to the square root of negative 1. So x is equal to plus or minus the square root of negative 1 times 5. And I'm taking some extra steps. Once you do this enough times, you don't have to do all of these steps in the middle. You can go from this to your plus or minus. Plus or minus square root of 5i. So you'd have square root of 5i and comma negative square root of 5i will be your two solutions. And remember, that's not an I you pick off your keyboard. It's down there at the bottom. It'll be a selection that you have.
Before you move, are we still doing number 6?
Almost forgot.
We're done with number 6. Yes.
Okay, number 3. I'm sorry to go all the way back, but I'm missing the last, like what the actual answer was that came out on number 3. I got I know that's going way back.
From this one is 2, and from this one was negative 11/5.
Okay, maybe it's number 2 that I'm missing because I got negative 8 and 1.
8 and negative 1.
8 and negative 1. Okay. All right. Thank you. That's all. From that part.
Are you, did you get 3?
Yeah, I got 3. That's yeah.
All right. Okay, let's go to 7.
I have a question about 6.
Okay.
How are we to know that there's that imaginary number in there?
Because it's the square root of a negative number. You can't have the square root of a negative number. If you do a square root of a negative number on your calculator, it's going to give you an error unless you've got it set to do complex form. But let's see what it does. I don't remember if I have mine set in complex or not. But let's see what it says. If you do second square root negative 5, enter. Yeah, it tells you there's an error. And it tells you that it's non-real. It's a non-real answer.
Okay. Okay, thanks.
Now you can set your mode so that you do get I's in here, but as we leave it like that, then you'll know if it gives me an error, then I've got to check an I out. But
So
you can't have a negative underneath the square root.
it'll always be a -1 though, right? Because
Yes.
we're timesing it. Okay. To get
It's
the same
always -1 because that's your definition of I. It's the square root of -1.
Okay.
That's how you're getting that -1 times whatever number that is there.
Thank you.
You're welcome. Any other questions? Good questions tonight. Okay, let's try number 7. X squared plus 4 equals 0. Notice we don't have an x term, so we're going to subtract this 4 from both sides, and we'll have x squared equals -4. We're going to use the square root method, so we get plus or minus the square root of -4. There's that negative again. So we're going to get x equals plus or minus the square root of -1 times 4, which is plus or minus the square root of -1 times the square root of 4, which is plus or minus the square root of 4 is 2, and the square root of -1 is I. So I have an answer of 2i and -2i.
Can you leave this up for a second? I'm still writing. It's kind of takes me longer to write the square root symbol over everything.
Okay. Just tell me when you're ready.
I have another question. Now it has that 4 there, so you just divided it to make it a 2. So if it's a 12 there or something, we'll just make it a 6?
No. The
Okay.
square root of 4 is 2 because 2 times 2 is 4. It's a
Right.
perfect square. But 12 is not a perfect square. It's 4 times 3. I could split it up and say, if it was the square root of 12, I could say the square root of 4 times the square root of 3. And then I would have 2 square roots of 3 if it were 12.
Okay.
You have to have these perfect squares in there. It just happens that 4 is a perfect square because 2 times 2 is 4.
Okay, I get it.
Those perfect squares are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. And sometimes if you're not used to doing this, it's a good idea to make you a list of like the first 10 or so perfect squares. And that way you'll see them when you see them in these numbers. You'll go, oh yeah, that's got a 9 in it. 9 times 5 is 45, so that's a 9.
So it's pretty much a number times a number. It will give you a square root if you can easily divide it into 2.
No, you're not dividing it into 2. You're multiplying it by itself to get the perfect square. 1
Okay.
times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. That will make the perfect square. So the square root of 36 is 6. The square root of 25 is 5. The square root of 16 is 4, and so on. But they're perfect squares because it's a number times itself. Does that help?
It does. Thank you.
All right, let's try this one. This one's different. So I hope those college algebra students hung around a little bit. Now, you would think that you could just divide out that 5 and be in good shape. But this one does have a linear number. It's not just a 45. See, this one up here just had this 4. There was no X on it. But this one's got an R on it. That's an R. I guess I should make it an R like this. Okay, that's an R. So I can't just divide out the 5 on these. That's what people always do. And that is not correct. Can't spell divide. Can't divide out the 5. What you've got to do is set this thing equal to 0. So I'm going to subtract this 45R from both sides. And I'll have 5R squared minus 45R equals 0. And I have to do that as opposed to up here because the 4 didn't have a linear term with it. It's just a plain number. It's called a constant. Whereas in this one, there's this little attachment right here of this R. It's a different kind of problem. So be aware of that. Now, again, you can always do this by the quadratic formula. You'd have to still bring your 45 over. And your A would be 5, your B would be negative 45, and your C would be 0. You can
What
still
was the
do
question asking?
I'm sorry?
What was the question asking? I'm confused.
It's asking you to solve. All of these are solve.
Oh, okay. So it was equal to each other. I wrote it down wrong. I'm like really confused.
this one is equal to this one. Did you get that?
Okay, so equals and then you, okay.
Okay, you subtract the 45 from both sides, 45R. Now then, take out a GCF, 5R, and you'll have a R minus 9.
Okay.
Now you set each factor equal to 0. You got to set this one and this one equal to 0. 5R equal to 0. Divide out the 5, and R equals 0. R minus 9 equals to 0. Add the 9, and R equals 9. This one's different from this one because this one has it's called the linear term on it.
Okay.
Okay. All right, let's try another one. Let's try number 9. Number 9 is 5y cubed minus 44y squared minus 9y equals 0. This is a cubic equation, so it's going to have 3 answers or 3 solutions or 3 x-intercepts or 3 zeros.
Does that say 49 or 44
I'm
y
sorry.
squared?
44. I'll try to be more.
Okay, thank you. Sorry.
It's okay. Just ask me. I want you to have it right. Okay, the first thing you want to do is factor out this common y. There's a y in each place. So you have 5y squared. You're getting it down to quadratic minus 44y.
Hey, Miss Sullivan,
Uh-huh.
the way that you taught us last spring, where you write the Y's below may help some people because that helped me a lot last semester.
Oh,
Like where
okay.
you write out all the Y's so you can mark them out.
Like this.
Yeah, I don't know if that'll help anybody else, but it helped me.
They have a y in common, so if you take out a y out of each one of these, then you'll have a y squared left and a
Brooke,
y left.
Brooke, that made sense. Thank you. That helped.
That does.
I
make
was show
a lot of
like
sense.
where did that go? But then I saw that she had the Y in the front. So I'm like, okay, well maybe she just took one away. But Brooke, that did make sense. Thank you.
Hey, she's the one that taught me that. I just remembered it.
Well, thank
Thank
you,
you, Dr.
Brooke.
Sullivan.
Sometimes I forget to break it down to that low when we're in this class. And so thank you for reminding me. I appreciate that. Yeah, that's the way we start out learning how to do the GCFs, is breaking those up. Okay, now then, this is an AC trinomial, guys. See, there's a 5 and a 9. So I'm going to multiply 5 times 9, and I'm going to get 45. Then I look at the last one. This means I must subtract. Factors of 45, not just 9. Subtract 45 to get 44. Well, that's pretty easy. 45 and 1, if I subtract those, I get 44. I want my 45 to be negative and my 1 to be positive because I want a negative 44. All right, let's go through those steps again. I want you to forget that that y is there. So put your thumb or your finger over the y. And let's just bring down the first term. I'm not going to rewrite the directions. They're on the other sheet. Bring down the last term. Rename the middle term. Now, this is quadratic, so you could use quadratic formula for this part of it. My middle term that I'm bringing down, I'm going to use these values over here. Negative 45y plus 1y. That negative 45y plus 1y will make the negative 44y. I split it up. And I didn't just do it with any numbers. I did it with the numbers that using that 45 to subtract to get 44. It was a method for doing that. Okay, now group it. So let's see if I can do it like Brooke wanted me to. 5y and y, and 9 and 5 and y. If I break up those. So I can see that they have a 5 in common and a y in common. So I have a 5y That leaves me with y, my sign is minus 9. Now over here, I don't have a negative third term, so I'm okay. I can just take out a positive something, but I have to take out something. So 1 and 9 have a 1 in common. So I put a 1 there. And so do you see that I get y minus 9? I don't change the sign because I took out a positive 1 instead of a negative 1. And look, it's magic. It's always magic. I love this because it's magic. Those are always the same if you did it right. So this time I'll put the fronts in the first one. 5y plus 1. That's the ones under here. That's going to make up one of the little parentheses. And the other one is the common group, y minus 9. Now this is where you want to remove your finger and bring down that y that was up there. It gets in the way if you try to keep it there the whole way. Okay, now we've got this one and this one and this one to set equal to 0. So we have y equals 0 from the first one. 5y plus 1 equals to 0. Gives me 5y equals negative 1. Divide by 5 and you get y equals negative 1/5. And the third one is y minus 9 equals 0. And that one gives you y equals 9. So your three numbers are 0, negative 1/5, and 9.
I have a question. Can you explain where you got 0?
It came from this y that I factored out initially. It came down here, and so I have three factors. I have y, I have 5y plus 1, and I have y minus 9. I have to set all three of those. Remember, this is cubic, so I'm going to have three answers. I set each one of those equal to 0 and solve it. So I have to have this y equal to 0 as part of it. And it came from originally when I factored out that y.
Okay.
I had to do that at the beginning because they have a common DCF in each one of them. And I took it out, and it's here, but I didn't use it again until down at the bottom.
I think this one was more difficult than the last one we did.
Yeah, it's a step up from the last one.
Yeah, all these are way difficult than anything we've done.
I mean, we did a problem like this like a few minutes ago, but
Yeah,
this
we
one's
did this
better.
part of it a few minutes ago. We didn't do it with the y that was out in front.
Right.
It changed it from a quadratic to a cubic is what this problem's done. So we have three roots, three answers. Whatever your highest exponent is on these will be how many answers you have.
So how do you know when it's an AC term and whatever it's called?
Well, when you put this one's an A, you know, and this is a B, and this is a C, like in the quadratic formula. If there's a number in A other than 1, then it's called an AC trinomial. And you
Okay,
actually,
so if it's anything other than 1, then you do it this way.
and it's called AC because it's telling you have to multiply A and C together. It's called an AC trinomial because of that reason.
Okay, that makes sense. Thank you.
You're welcome. Any other questions?
So I have one. So whenever you got down to where you were combining the terms right under where we took the y, where you just put the ABC at the top.
Right here.
So the line down, yeah.
Right here.
This one, yes. So why did we, if we factored out that 5y from that first variable, why did we pull another one down?
Why did you pull another, why did we pull this y down?
No, why did we pull the 5y down if we factored it out?
because it's only factored out of this little group right here. It's not factored out of the whole thing. This is actually makes a problem right here.
Okay. Gotcha.
And this is one term right here.
Hmm.
And this is the other term. And really what you're factoring out is this common one. This is the factored out term. This is the common factor. This is what's left over of each factor when you take it's like up here when I slashed out these y's. If I slash out this y minus 9 in both of them, what you have left in this term is 5y, and what you have left in this term is 1. And those together make a parentheses by themselves.
Got it. Thank you.
Any other questions? I won't tell you these are easy. I tell you that these need practice. You just got to practice them. They're not hard. They're just they're just needing practice. I don't think they're easy and I don't think they're hard. They're kind of in the middle somewhere. Just got to practice them. You know how I got a doctorate? Just how do you think I got a doctorate? Huh? It wasn't because I was smart. It was because
you was practiced
I
a lot.
practiced and I was persistent and I didn't give up. And that's just the whole secret of doing pretty much anything in life. Just don't give up. Just keep at it until you get it. That's what happened. I'm just too stubborn to give up. I just kept trying and trying and trying until I got it. And you know, I kept looking at people that graduated ahead of me and I thought, you know what? I think I can do it if they did it. I really do. So I just kept going back and just trying it again and trying it again. And you can do that too. It just takes persistence. That's a new word that one of my grandchildren's learning, and I'm trying to get him to use it in lots of sentences because I want him to be persistent too. That's all it takes. It doesn't take smarts. And like I said to you guys, some of you didn't do as well on the test as you wanted to, but it had nothing to do with your brain power. It had everything to do with what happened in your life. So just don't beat yourself up over this. If you could take it at any other point in time, might make a difference. We're going to factor this in by grouping, and this one won't be hard because we've been practicing grouping. So this one should not be hard for us. So, okay, Brooke, I'm going to do this since you reminded me about it. If I have an x and an x, and this one has an 8, and an x and an x, what do they have in common?
They have an x squared in common. I think it helps me because you're able to see where they're coming from.
Oh, well, I'm glad you mentioned it. Oops. This has got to be 1 because I took all the x's out. Does that look like 1? Maybe I need to rewrite that. X squared 8x plus 1. There's always a 1 out in front of that. Okay, now the third term is negative, so I have to take out a negative something. What is it going to be for 32 and 4?
-4.
4 and 8 is 32, and 4 and 1 is 4. So I can take out a 4, and it, like Brooke said, it has to be negative because the third term's negative. That's going to change the sign of the -32, and I'm going to take out the 4, which is going to make an 8x. If you think ahead, you're going to want this, so see if you're going to get it. Take out the negative, makes it a plus. Take out the 4, makes it a 1. And now, can you do it? Have you got it down? This is your common one. You can put it in the front or you can put it second. And then you put another parentheses right next to it. Don't put anything in between it. And then what do we put on the second parenthesis?
The
X squared
8x
X squared minus 4.
Good. Now then you said each one of these equal to 0. And this one's a squared term. So notice it's a cube. It's going to tell me that I got 3 answers. I have subtract 1. I get 8x is equal to -1. Divide out the 8, and I get -1/8. Add 4. I have x squared equals 4. And this is the square root method. So I'm doing plus or minus the square root of 4. Don't forget your plus or minus on that squared. So x is equal to plus or minus 2. So my answers are 2, -2, and I think we did this one earlier. It's the same problem. Okay. All
Can I
right.
leave that up just a little bit? I was still writing. I'm sorry.
Okay. I know that Brooke knows this, but guys, it took me 10 years to get my bachelor's degree. I went to college right out of high school, got married, ran out of money, had to get a job, had to quit school, went back to school,
Me too.
got pregnant, had to quit,
Same here.
stopped, had to work, went back to school.
Except for the getting pregnant part. I didn't do that.
Well, I'm glad to hear that.
Well, Billy, if you got pregnant, you wouldn't need to be in college.
You'd have plenty of money. So
That's
then
right.
I got pregnant again and had to quit. Then I had to go to work because I had no money. And, it's just a cycle. And by the time I finally got to the point where I could almost graduate, they changed all the rules on me, and I had all these extra classes to take to be able to finish my degree. So,
Boo.
it just
Okay.
took forever to do it. And so, but I did it. Finally
I'm
did it.
finished now.
10 years it took to get my bachelor's.
That's what happened to my nursing, except I had to add a divorce in there with all them twins. But I'm back. I'm ready.
You can do it. You can do it. Okay. It says use the graph, and it has a graph just like this. And there's a mark right here. And then there's 1, 2, 3, 4, 5. There's a mark right here. And then there's a parabola that's drawn down through here. And the question says use the graph and find the x-intercepts. And it says write as an ordered pair. I thought there was one of these. Write as an ordered pair. So it looks like 1, 2, 3, 4. This is -4, 0. 1, 2, 3, 4, 5. This is 5, 0. So I would put, it says also to put a comma between them. So I would do -4, 0, comma, 5, 0 for that part. Then there's a second question that pops up and says the zeros are, and it says use a comma. Okay, and it just has this blank. So what would we do about that?
Wouldn't it be -4 and 5?
Yep. So see the difference? If they want it as x-intercepts and actually specify that they want an ordered pair, you'll put it like this. If they want the zeros, or they say roots, sometimes they'll say roots, sometimes they'll say solutions. any of those numbers, words, they'll want it like this.
So the x-intercepts are basically the points that are on the x-axis, and the zeros are the x's.
Yes. And they're called zeros because it's where y is 0. That's why they're called zeros, because you set it. Remember those problems that we set equal to 0? This would be the y value, and they're called zeros
Right.
because you're setting them equal to 0. Okay, let's try. 12 is just like this one where you have to do the intercepts. I think you can probably do this problem. Anyone that needs another one of those to look at? Are we good? All right, let's do number 13. It actually says use the quadratic formula to do it. It doesn't say for you to do it any other way. X squared minus 2x equals 35 is the problem. And you have to remember that you are finding zeros. So this has to be a 0 over here. So you'll have to subtract your 35 before you can start this problem. And identify what your A and B and C is. A is 1, B is -2, and C is -35. And pretty much people know how to do these. The only thing that I have problems with students getting them wrong is not putting these in parentheses in your quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? You got it memorized yet? All right, so we have -2 plus or minus the square root of -2 squared minus 4 times 1 times -35. I'm going to multiply that.
Can you, when you're done with this, just leave it up for a minute so I can write all this down? I can't write this fast.
Can I write faster than you can?
Yes, actually, I'm very impressed.
I will tell you that all of these are already written out for you in content, you know. Do you remember that? Do you guys remember that?
Yeah, but it helps me learn it, like when I write it down with you.
Okay.
I know I'm trying to keep
Right.
up with you.
All right,
It
it's
just
okay.
helps
I don't
me.
mind. I just wanted to let you know they really are already written for you. But you're right. Sometimes when you're looking at the whole, all of them together, it's a lot harder than if you just do it individually, each line.
Like even with the homework, like when I do it, I'll actually write it out while I'm doing the homework on a paper with each problem because it just helps me like grasp what to do on each step. And then if I mess up, I know like where I did it.
That's a good way to do it, actually. All right, this is going to make a +2. And let's see what this is going to be. -2 squared is 4. -2 times -2 is 4. And this negative times this negative is going to make a positive something over here. And 4 times 35, what is that? 140? Is that right? Okay. So now I'm going to come up here and I'm going to say that's 2 plus or minus the square root of 144 over 2. Now somebody tell me, is 144 a perfect square?
Yes.
It sure is. What's the square root of 144?
12.
12.
So I can say that's 2 plus or minus 12 over 2. Okay, that's going to split into 2 parts. 2 plus 12 over 2 and 2 minus 12 over 2. That's what that plus or minus does. It splits it into 2 parts, one with plus 12 and one with minus 12. Okay, 2 plus 12 over 2 is 14 over 2, and 14 over 2 is 7. 2 minus 12 is negative 10 over 2, and negative 10 over 2 is negative 5. So those points are 7 and negative 5. How are we doing? We okay?
I think so, but I'm not sure. My brain hurts.
Does it?
Yeah, there's too many exceptions and rules and steps and
Well, you know what? You can always use the quadratic formula.
It's just complicated.
yeah, and then it doesn't give you a convenient answer for that problem.
Why?
I'll say that the quadratic formula is easier than the cubic formula. I'm not down with the cubic.
I'm not just talking about this. I'm not just talking about this problem. It's this topic in general.
Just solving quadratic equations.
All of it is busy. But
You can do it, guys. All you have to do is just keep at it. Let's try this one. X squared minus x plus 4 equals 0. It's already solved for 0. I can't add factors of 4 to get 1. That's not going to work. So I'm going to use the quadratic formula. What is the A?
1.
Huh?
1.
What's the B?
1.
Negative 1. What's the C?
4.
4. It's the coefficients of the numbers that are the coefficients that are in front of those letters. All right, so let's try the quadratic formula. Have you memorized it yet? Negative b plus or minus the square root of b squared minus 4ac over 2a. All right, let's try it. Negative b. The negative's there in the formula. B is negative 1. I put it in parentheses. Remember to put these things in parentheses and they'll keep you from messing up. B is negative 1. I'm going to square it. Minus 4 times 1 times 4. All over 2 times 1. That together is going to make 1. And negative 1 squared is 1. And 4 times 4 is 16 times 1 is 16. And we have a 2 in the bottom. So we have a negative 15. Anybody know what we're going to do now?
The even more complicated stuff.
Well,
Will it be
something
1
we've
over
already
2?
done. What is it?
1 over 2 and then 15, negative 15 over 2?
Yeah, but you got to do something before we do that. That is correct. We're going to write it in complex form.
Get the I equal.
Ah, that's it. Who said that?
Marlisha.
Oh, Marlisha, you're so smart. You need an I out. Got that negative under there. So you're going to do 1 plus or minus the square root of negative 1 times 15 over 2. And remember, the square root of negative 1 is I, plus or minus the square root of negative 1 times the square root of 15. I'm sorry I'm writing fast. I come from the era of life where professors who wrote on the board erased what they wrote with the right hand with their left hand as they were doing it. So if you weren't fast enough to write it down before their left hand hit where their right hand had been, you didn't get it. They held the eraser in their left hand and wrote with their right hand. So I had to learn to write fast
You mean you use paper and pencil every day?
every
I'm just
single
kidding. I
day.
did too. I'm
Well, my son-in-law thinks I wrote with slates, but he's not right. He's not right in the brain.
Who asked that? Like everything used to be paper and pencil.
I was
Yeah.
kidding because like my daughter last week had to use paper and pencil at school and she didn't know what to do with herself because they use computers every day.
I know it.
Scary. That's really scary. I'm sorry.
Wait till they ask you what the telephone jacks and the walls are.
Oh, yeah.
I know it. My house used to be a police substation, so I've got all these jacks along the wall in this room, and the grandkids just can't get over that. What are those things? Well, they're used to help me for telephones.
My
Okay.
daughter was taken away by the fact that we used to have house numbers and not cell phones. We're like, you had to call somebody while they were at home.
I know it. Things have really changed. So whoever it was that said we had to write this in complex form is absolutely right. The two answers are going to be 1/2 plus the square root of 15 over 2i and 1/2 minus the square root of 15 over 2i. See how I split up that denominator into that 1 over 2 and square root of 15 over 2?
So this is how exactly right it. The I comes after that.
Yes. If you
Okay,
don't
so I
put
wanna
the
make
I
sure I
after
put
it,
it
I don't think
after
you'll
it,
count
right.
it. It has to be in that A plus BI form, which is called the complex form.
A plus BI, that's correct. Okay, thanks. I just want to make sure because like I've had a couple times where I've entered a problem, then it flagged it wrong because I didn't do the format proper.
That's right. All right, this is the last one, and then I can stay and help anybody that wants to have some help with factoring. I can help you. This one is 5x squared plus 6x equals -5. And it's not equal to 0 there, so I'll have to set it equal to 0 by bringing that 5 over. And if I wanted to try to factor it, 5 times 5 is 25. This is an AC trinomial, but I can't add factors to 25 to get 6. That's not possible. So I'm going to let A equal to 5, B equal to 6, and C equal to 5. If you people are headed for business, if you headed for business, you'll be doing this a lot. Those are called break-even points in business. So you'll be doing a lot of this kind of stuff if you're headed that direction.
I'm
So,
thankful I'm not headed that direction.
do what?
I said I'm thankful I'm not headed that direction.
Okay, so we have negative parentheses 6 squared minus 4 times 5 times 5 all over 2 times 5. Don't forget to draw your line all the way over. So this one's going to be -6. 36 minus 20 times 5. That's 100, isn't it? Okay. Everybody with me? I appreciate you all staying. So I have -6 plus or minus the square root of -64. Are you thinking ahead about what we're going to need to do? Is 64 a perfect square?
Yes.
Yes.
But there's a negative there. So what do I do about that negative?
Do that.
So I'm going to do
Put
negative
I
4
after.
times 64. And so now I have negative 6 plus or minus square root of negative 1 times square root of 64. Now some of you can skip that step. Plus or minus square root of 64 is 8. Square root of negative 1 is I. So I have 8I over 10. This one's kind of interesting. So if I split it up, I get negative 6 over 10 plus or minus 8 over 10I. And if I put that in, it's going to be wrong. Why?
Simplify.
Yeah, these have got to be reduced. So that's going to be negative 6 over 10 plus or minus 8/10 I. That would be divided by 2, and I would have negative 3/5 plus or minus 4/5 I. So my two roots would be negative 3/5 plus 4/5 I, and negative 3/5 minus 4/5 I. You guys did really well tonight. Okay. It's 8 o'clock. Do y'all have any final words of wisdom or questions? And if you want to stay for a minute, I'll go over some factoring with you if you want.
If you could just go over, I think the last part we did Tuesday. First part was okay, but the last part I was like, yeah, I stopped. I started on it, but I stopped.
The last part when?
Tuesday, 7 o'clock, I believe it was.
The 7.2
Yes, ma'am.
section?
Just maybe 2 of them, and then I should be fine.
Okay. 7.2. Okay. Those are the shifts, aren't they? Are those the shifts?
Yes, ma'am.
Okay, okay. All right, guys, if you don't need to see the shifts, get in there and work. Thank goodness it's the weekend. You do have until Sunday night at midnight to get this